Alright guys, purpose of this video is to start looking at a different type of bonding. So far we've been looking at ions and ionic bonding and how ions are positive and negative particles that are attracted to each other because of their difference in charges and that they've transferred electrons. So metals have lost electrons and become positive ions, and non-metals have picked them up and become negative ions, and then they stick together, and that's ionic bonding. Today's lesson, or today's little video, is on covalent bonding, which is a different type of bonding. And it occurs between two non-metals. Okay, so unlike ionic bonding, which was between a metal and a non-metal, we're now going to have a look at what covalent bonding is, which is between two non-metals. So to do that, we're going to have a look at a non-metal, and we're going to use fluorine as our example, F. And we know that fluorine has, if you check the table, he has 7 valence electrons. Remember, it's all about the valence electrons with bonding, because bonding is, atoms are always trying to bond because they're trying to fill that outer shell. They're trying to be as stable as possible, and that they'll fill that outer shell however they possibly can. Ions do that by either losing electrons or gaining electrons until they have a full outer shell. But in this case, we're going to look at how atoms share electrons. Okay, so fluorine has 7 valence electrons. I'm going to draw them in. So 1, 2, 3, 4, 5, 6, 7. So he's got one free spot here. He's missing 1 electron. Now if he was to come across a metal like a sodium, someone who was happy to give it up, he would rip it off sodium and form a negative ion. But sometimes they don't come across metals, things that are happy to give up electrons. What if he comes across, instead of a metal, what if he comes across himself? What if he comes across another fluorine atom? So I'm going to draw it a different colour just so that we can see this. But what if he happens to come across another fluorine? And this fluorine is the same as him. He's got 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So he's also missing 1 electron. Both of these atoms are unstable right now. They're both very reactive. They're both looking to fill that outer shell. But they're both really good at holding on to their electrons, and so no one's really going to give them up. Nobody's willing to transfer an electron like in an ionic bond. Both of them are really keen to grab and gain electrons, and so how can these guys mutually come together and be happy? Well, they do it by sharing electrons. They work out the fact that, you know what, if I was to share this electron with you, and you were to share this electron with me, we could both be happy, right? And happy means we're stable, we've got full outer shells. And so what happens is, this fluorine here comes together. He keeps all these valence electrons, but he shares that middle electron, and the other fluorine atom also comes together. And you can see what happens here is that they're sharing a pair of electrons. Sharing electrons. That sharing is actually a bond. And that bond is not an ionic bond in this case, but that is a covalent bond. So what it looks like, another way of drawing this is we draw our F, and we draw our bond, and we draw our other F. And this bond here is really like chemists saying, these guys are sharing electrons. And this is called a covalent bond. Covalent bond means sharing electrons. So unlike ions have transferred. One atom gives up an electron, the other one takes it. And in this case, they're sharing. Now, you can see that if they share, they are both stable and they're both happy. Remember, they're trying to achieve a full outer shell. And if we go around and count these, for both fluorine atoms, they have done that through the sharing, right? So we got 1, 2, 3, 4, 5, 6, 7, 8 for the red fluorine atom, and 1, 2, 3, 4, 5, 6, 7, 8 for the blue fluorine atom. So they've actually formed a molecule that's covalently bonded this time, where they've shared electrons, and this molecule is called fluorine. So it's a fluorine molecule. Okay, so this is a covalent bond. Covalent bonds are sharing. They're formed between two nonmetals, so you'll see that they're both nonmetals this time. And so covalent bonds is about nonmetals sharing electrons so that they are happy and that they are stable. We will do one more here in this video just to give you an indication. Let's have a look at hydrogen very quickly. Okay, so we're going to go all the way down here. The hydrogen atom, he has one valence electron in his first shell. If he comes across, let's say a fluorine, because we've been doing fluorine, he has 1, 2, 3, 4, 5, 6, 7 valence electrons. If these guys come together, they will actually form a covalent bond as well. And what happens is hydrogen, remember hydrogen's only got one electron in his outer shell, and that first shell only needs 2, so he's only missing 1. He's only got 1 free spot. Fluorine's got 1 free spot. And so they go, okay, what if we share? I'll share with you, you share with me, we scratch each other's backs, and we come together. So this hydrogen here shares his 1 valence electron. Fluorine shares it and has some of his own. Important thing to note here, all the other electrons of fluorines are his still. He's not sharing these. The only ones that he's sharing is these two here. So that is the electrons that are shared. So those are the electrons that end up making the hydrogen fluoride molecule. And that guy there is our covalent bond. Awesome. So, summary, covalent bonds are formed between two nonmetals. So it could be the same nonmetal, it could be a different nonmetal. And they're formed because nonmetals are typically looking to gain electrons, and so they both are looking to gain. So instead of one taking an electron from another, they share a pair or multiple pairs of electrons, and we can look at that in future videos. And when they do that, they form a covalent bond, and they are happy. They now have 8 valence electrons each, or in this case, hydrogen has his 2 that he needs for his first shell to be full, and that makes them stable. And that makes little molecules called molecular compounds. We'll talk about their properties in the future, but typically molecular compounds are different to ionic compounds. They don't form crystals, they just form little discrete molecules that exist as separate molecules. They don't build crystals like the ionic compounds because there's no charges. All right, hope that was helpful.